class we will learn how to geometrically interpret the nth root of a complex number. As I mentioned to you, omega is the nth root of the complex number z, and we have found that omega to be equal to r raised to the power 1 over n of cos of theta positive 2k pi divided by n positive I times sine of theta positive 2k pi divided by n. Okay, this is the representation we have got. Now we know that if z is any complex number, then I can write it as r times e power I theta. Now e power I theta is actually equal to cos theta positive I times sine theta. Okay, we have studied all this. Now using this representation for e, I can write omega to be equal to r raised to the power 1 over n of, this is going to be e raised to the power of I. The argument is theta positive 2k pi divided by n. Okay, so this is the representation I have got. Now you have to understand that the magnitude will always be same for all of the complex, or in other words for all of the nth roots, so there wouldn't be any change at all. So the nth roots, you can say the nth roots all have the same modulus. Okay, and that is r raised to the power 1 over n. You can either write it like this or nth root of r. Okay, and not only that, all of the nth roots are equally spaced. Okay, that means the distance between two nth root would be 2 pi divided by n. Okay, so these are some of the basic informations you have to know, and that is how we represent the, or in other words, we interpret the nth root of a complex number geometrically. Now if someone were to ask you what is the modulus of the nth root, then that representation is done like this: the mod of omega is equal to r raised to the power 1 over n. Okay, so this is the way we represent it. Further, we can say that all of the nth root of z will lie in the circle, okay, of radius nth root of r, or you can write it as r raised to the power 1 over n. So this is a very important interpretation